Going ahead, let's talk about uniform motion and non-uniform motion, and let's talk about two more terms, average speed and average velocity. What is uniform motion and what is non-uniform motion? At the beginning of the chapter, we already saw the definition of motion, wherein we defined it as a movement of some kind. So what is uniform motion? Uniform motion, listen very carefully, I'm writing it as well, is nothing but when a body or an object covers equal distances in equal intervals of time, that is uniform motion. So, an example could be, I repeat, equal distances in equal intervals of time is known as uniform motion. So, say an athlete is running 500 meters race and he's covering 100 meters in every 12 seconds. Okay, individually, as per the second, his speed might vary. As per 2-3 seconds, his speed might vary. But every 12 seconds, if you notice, the first 12 seconds he's covered 100 meters. Another 12 seconds he's covered 100 meters. Another 12 seconds he's covered the 300 meter. Another 12 seconds he's covered the 400 meter. Another 12 seconds he's covered the 500 meter. In other words, in all the 12-second intervals, he's covered 100, 100, 100, 100, 100, 100 meters, and cumulatively after 60 seconds he's completed his 500 meter race. So that is an example of uniform motion. Another example of uniform motion, let's say a car is being driven from Pune to Mumbai. Typically, for those who frequent Mumbai regularly would know that the distance is about 3 to 4 hours. So let's say in every hour the car covered approx 60 kilometers. In the first hour also 60 kilometers, the second hour also 60 kilometers, the third hour also 60 kilometers. The speed is going up and down, but the hourly interval is constant. And eventually at the end of the third hour, you have reached Mumbai. That is an example of uniform motion. That is equal distances in equal intervals of time. Then what is non-uniform motion? Non-uniform motion is obviously the opposite of this. Unequal distances in equal intervals of time. Unequal distances in equal intervals of time. The same athlete example I gave you can be flipped now. In every 12-second interval, he's covering variable distances. Let's actually write this. So in the case of uniform motion, our athlete has covered 100 meters in every 12 seconds. In the case of non-uniform motion, in every 12-second interval, there is a variable distance covered. This is an example of non-uniform motions, unequal distances in equal intervals of time. The same Pune-Mumbai journey can be considered in 3 hours, where unequal distances were covered. 100 kilometers were covered, say, in the first hour, 60 kilometers in the second hour, and a lot of traffic, so 20 kilometers in the third hour. Unequal distances in equal intervals of time. So that is an example of non-uniform motion. Moving ahead, what is average speed? What is average velocity? In the earlier part of the chapter, we just saw speed as distance upon time. We saw displacement we saw velocity as displacement upon time. So what is average speed and average velocity? For though I am not sure if you must have been exposed to averages, possibly you have been. Average is, say there are 10 of you, or like maybe 13, 14 of you from what I checked your papers. How will I, if I want to know what is the average score of our class for a particular test, I'll tally the marks of all of you 14, if you 14 have given the test, that is, all 14 have given the test, that is, divided by the number of students who gave the test, so upon 14. So if someone got 5, someone got 45, whatever, all the 14 marks are added upon the total number of students who attempted that test. So in other words, an average can be defined as sum of total observations upon the total number of observations. So how do I define average speed and average velocity then? Average speed can be simply defined as the total speed, or rather total distance upon total time. Total amount of distance covered upon the total amount of time taken to cover that particular distance. What then is average velocity? This is slightly complicated because of this word called displacement. It can be variable at variable points, it can be positive, it can be negative, it can be zero, because it is entirely dependent upon direction. So here, for the average velocity, we keep our frame of reference as initial velocity, the starting velocity only, plus final velocity. We have considered only two velocities, initial and the final. And how many velocities have been considered? Two. Like I said, the word average implies number of addition of the observations upon the total number of observations. So this will be 2. These words are too big, so we can denote both initial velocity and final velocity by a notation. Average velocity, or V average, can be given as U, which is initial velocity, plus V upon 2. So let us actually do some solved examples and some in-textbook questions of the numericals in the NCERT, because that will help us and really give us confidence for this chapter. The first NCERT solved example says that an object is traveling 16 meters in 4 seconds and is traveling 16 meters in another 2 seconds. What is the average speed? How do we do this? We just defined a little while ago average speed as the total distance upon the total time. So what is the average speed given by? This total distance upon total time, albeit in different time intervals. What is the total distance the object has covered, guys? It is 16 meters plus another 16 meters in 2 separate time intervals. And what is the total time in which this distance has been covered? It has been covered in 4 seconds plus 2 seconds. So this becomes, I can say 2 16s are 2 3s are, which is nothing but 5.33 meters per second. So average speed was total distance upon total time. The two distances were added, the two times were added. I got 16 by 3 and my average speed is 5.33 meters per second.